Go over the basics of probabilities, how to find them, and how to find combination probabilities. So what is a probability? Well, it's just the likelihood that something will happen. So to find a probability, I need to know two things: how many possible outcomes there are, and how many events are favorable to what I want to find. All right, so how do we find the probability? Well, it's just what I just said. We find the number of events that are probable for the probability we want to find and the total amount of outcomes possible, and we divide the two. All right, how do we express a probability? Well, it's basically just a ratio, okay? It's a ratio between the favorable events to the possible outcomes. So we can do this in any ratio form. That's decimals, fractions, or percents. All right, so let's do an example real quick. Let's say we're flipping a coin. What are our possible outcomes? Well, we could flip and get a heads, or we can flip and get a tails. Okay, so there are two possible outcomes. The other thing is we need to know what the favorable events are. So what are the favorable events that what we flip will be a head? Well, if there's only two options, only one of those options, this one, is in favor of flipping a heads. So the answer is 1. If I was going to write that as a fraction, it would be 1/2. As a decimal, it'd be 0.5. And as a percent, the probability would be 50%. All of these are the ways that I can write the probability. The probability is 1/2, the probability is 0.5, and the probability is 50%. All right, let's do another example. This time, let's roll a dice. If I roll the dice, what are the possible outcomes? Well, I could get a 1, a 2, a 3, a 4, a 5, or I could get a 6. So there are 6 total possible outcomes. All right, so how many are favorable of rolling a 4? Well, that's only one of the options. So for this one, the probability can be 1/6. It could be roughly 0.17 or 0.16. It's just an approximate. When we're dividing numbers like this, we're only going to get approximate. It's somewhere between 0.17 and 0.16. And you can look at that as either 17% or 16%. I'm going to look at it as 17. So the probability can either be 1/6, it could be 0.17, or it can be 17%. And I get all of this by dividing my 1 and my 6. So divide the 6 into the 1. So let's take a look at combinations. Okay, I can have and probabilities and I can have or probabilities, and this is where we either have two different events that happen. I either roll a dice and pick a card, or I pick two cards out of a deck. There are two things going on. There are multiple things. We could have 3 things going on, 4 things going on, but because it's hard to calculate those, and that's when we start getting into needing a calculator or a computer program, we're just going to stick to 2 things going on. So let's look at some examples of combinations. There'll either be an and probability or an or probability, and you have to be very concerned about the wording. So in this one, we're going to roll a dice and flip a coin. Okay, so first I need to know how many outcomes are there for rolling a dice. Well, if I roll a dice, there are 6 different outcomes I could get: a 1, a 2, a 3, a 4, a 5, or a 6. Okay, and I'm going to flip a coin, which has 2 outcomes. I can either flip heads or I can flip tails. Because it's an and probability, we multiply the outcomes. That is going to give us 12 total outcomes for our probability. Okay, we could also do this by creating a sample space with a tree diagram. All right, so to create a tree diagram, I write down my very first event. My first event is I am going to roll a dice. When I roll that dice, I have the options of getting a 1, a 2, a 3, a 4, a 5, or a 6. In my second event, I am going to flip a coin. Now, a coin only has 2 different things that could happen. So the first combination that can happen is I can roll a 1, and then I could either flip a heads or flip a tails. Okay, and then the next combination that could happen is I could roll a 2, and then I could flip heads or flip a tails. And then with my third possibility, I could roll the 3, and then again, it's just heads and tails. And this pattern just follows the whole way through. I'm just listing everything that could happen, okay? And this just helps us to figure out different probabilities, all right? So again, I could roll a 5, and then I could flip either a heads or a tails. And this is really good if you're trying to figure out pro and con lists that are combinations of different things you could do. If you're super mathy, nerdy like I am. Now, the next thing you need to do is write a sample space. A sample space is just writing all your combinations out. It's not really necessary if you can read your tree diagram right, but a lot of times if you're taking a class, they want the sample space. Another good way for it is so that you can draw all over it. A lot of times I'll make tons of sample spaces. That way I can draw all over them while I'm trying to figure out different things. So I'm going to call heads H and tails T. So my first option, I just follow my tree. I can roll a 1, I can flip a heads. I can roll a 1, I can flip a tails. Then follow my tree, 2 to heads, 2 to tails, 3 heads, 3 tails, 4 heads, 4 tails, 5 heads, 5 tails, and 6 heads, 6 tails. Now remember I said there were 12 possibilities. So let's count up our possibilities. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I got the same thing doing my sample space. Okay, so let's look at some different things that can happen. So I'm going to write over here some different things that can happen. Okay, so let's say the first probability I want to find is the probability of flipping heads in my little experiment when I'm doing my empirical probability, which I'm going to talk about in a minute. All right, I have a heads here, 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 and here. So I have 6 of them out of a total of 12 outcomes. Look what happens to this. If I reduce this fraction, it becomes 1/2. That's the probability of just flipping a heads, okay? So it still goes back to the original probability of flipping a heads, even when it's a combination. But if I want to know the probability of 2 different things happening, then it changes. Okay, so what if I want to know if I flip heads and I get a 1? Okay, so now I'm saying I have to flip a heads when I do my quarter flip, and I have to roll a 1. I have to do both. All right, and means to multiply the probabilities. So my probabilities of getting a head, I already know, is 1/2. Okay, my probability of getting a 1 is right, let me switch colors, right here and right here. So it's 2 out of 12. If I multiply the probabilities, I'm going to get 2 out of 24, which if I reduce down is 1/12. Look at the beauty. That's the mathematical way of doing it. But I could have done it with my tree diagram and sample space. The only option that I have in my sample space that is a heads and a 1. It has both things going on. It's this one option. None of the options have both H and 1 in it. So if I had just gone by my sample space, I would have quickly known that it was 1/12, because there's only one option that fulfills that out of 12. All right, let's look at OR probabilities. So an OR probability would say, what if I roll a 5? What's the probability of rolling a 5 or rolling or flipping a tails? Okay, so in this wording, I'm saying either or thing can happen. I could either roll a 5 or roll a tail. And it wants you, so those things are kind of separate. They're not together in their thinking, okay? I can do either or of them, okay? So this kind of means that I can add them. I'm taking just the probability of finding a 5 and adding in the probability of finding tails, but I cannot repeat myself, okay? So I'm going to cross out everything that has a 5 in it. There's just 2, right? There are 2 options in my sample space that have a 5. So it's 2/12. OR means to add. So now I'm going to cross out everything with a T. There's 5. This one has a T, but it's already crossed out. So remember, I said we cannot reuse data, okay? We cannot count it twice, okay? That would be redundant. So because it's already crossed out, I'm just going to do 5/12, okay? It's still 5 out of the 12. If I add it together, my 2 and my 5, I am going to get 7 out of 12 as my probability will be 7 times out of 12. I'm going to get a 5 or I can get a tails. Now I could have just done that again with my sample space. Look at everything that I crossed out. There's 1, 2, 3, 4, 5, 6, 7 options that I crossed out over 12. So I can either do it the mathematical way or I can do it the looking at my sample space way. So now let's talk about the different types of probability that there are. There are 2 different types of probability, theoretical and empirical. Theoretical is where we gather everything we know about the situation. We do some math using the likely outcomes over the total amount of outcomes in our situation, and we figure out a theoretical probability. This is what will probably happen. An empirical probability is where I flip a coin or I roll a dice, I do an experiment, I actually keep good track of all of my data during that experiment, and that data is what I create my probability off of. One is theoretical, one is more a little bit of real life. Now, both of these are very important. They should be close together. If I do theoretical probability and my empirical is totally out in left field, then something's wrong. And I need to compare the different events I use, the different circumstances that I use in my empirical, and I need to look at my theoretical and make sure my facts are correct and my math is good, because they shouldn't be too far off. Now, this is used a lot in game board design. Game board designers go through many phases of drafting their game. During these drafts, they use theoretical probability to figure out the different moves and make sure the game is something that we can win, but yet there's a bit of challenge. But then the real test of their probabilities come in empirical probability when they actually play the game. Now, these two need to be close together or something's wrong with their strategy and their layout of their game. But as we know, empirical is going to go a little bit off of theoretical in this particular scenario, because board games deal a lot with human error. There's a lot of human error in board games. The more human error we have, the more distance there could be between our theoretical and empirical probability. So to recap, they're both extremely important. Theoretical is where we figure out the probability by facts, by the math involved in finding probability, whereas empirical is where we actually do the experiment and find it in real life. If you like this video about probability, please like it below and subscribe to my channel. I have all kinds of videos already out and coming soon. You can also check me out at homeschoolmathmom.com, where I have tons of resources for all you homeschooling moms out there. I'm also at outschool.com, where I teach this stuff in classes for students under 18. So if you'd like to see me in person in a live online classroom, go to outschool.com and check me out.